So when we've been given the cosine ratio in the exact fraction form, what's nice about that is we actually have two sides of the triangle to work with. I have the x side and the radius side. So if I draw this in, I have 5 along the x. It's in quadrant 4, sorry. So it's quadrant 4. So 5 along the x, okay, and 8 along the hypotenuse or radius. And then I have an unknown side that I have to solve. Okay, so it says solve for theta and find sine and tan. I'm going to do sine and tan first by solving for this third side. So I'm going to go 8 squared minus 5 squared, so 64 minus 25. That's going to give me 39. So I'm going to end up with square root 39 as my radius. Sorry, not as my radius, as my y position. Okay, now mind you, it's going to be plus minus. Now it's important that we recognize that this is positioning. This is not root 39. It's going down root 39. Okay, so our positioning has to have the right sign. Okay, so once I've done that, I'm now ready to write my ratios, my trig ratios. I'm going to write my sine ratio. So sine theta equals, it's a negative sign in quadrant 4. Okay, cosine is to the right. Okay, so cosine is horizontal, so it's positive. Okay, we've actually been given that. And so we need to work out the tan ratio. The tan ratio, okay, it looks like negative slope. In fact, it's negative root 39 over run of 5. There's my slope. And notice I'm keeping it an exact value. Okay, that's very important. Keeping exact values. Now we're going to solve for theta. So when I solve for theta, and I'm going to call it theta 1 because my calculator always gives me theta 1, I'm going to use the arc cos. So here I've been given the ratio. I need to actually go backwards and solve for the angle. So I'm going to use the second function cos. My input is my ratio. My output is going to be my angle. So when I work this out, I end up with second cos 5 divided by 8 equals 51.32. So theta 1 is equal to 51.32 degrees. And when I look at that angle there, that looks reasonable. The problem is 51.32 degrees. Remember, this is all about position. Where's the position? What point does that locate? Well, unfortunately, it's not locating the right point because it's in quadrant 1. Okay, it's locating that point here. So that angle is 51.32 degrees. That's a quadrant 1 angle. That's not the one I'm looking for. I'm looking for the quadrant 4 angle, which is this angle measured all the way around to here. Now my calculator is not going to give this, but remember that there are two possibilities I have to consider. The first one doesn't work. I know the quadrant, so it must be the other one. Okay, so this is where I'm only going to give one solution because the quadrant is known. The location, specific location between these two is known. So theta 2, okay, I can go negative 51 degrees. That might be the easiest one to do, negative 51.32 degrees. That's the right position. Or you can go 360 minus that and go 300 and what's that going to be? 308.68 degrees. Okay, so if I go 308.68 degrees, I'm going to end up in the same position as negative 51.32. So these both are correct solutions, and those are coterminal. Okay, so this one here, we've been given the cos ratio. Again, the cos ratio given in exact form implies we have two sides of the right triangle. Okay, so cosine's negative in quadrant 3, so it's going to be down here. So it's going to be negative 3 -3, and 5 is my radius. Using Pythagoras, I'm going to end up with 25 minus 9 is 16. The square root of 16 is going to give us a side length of 4. Unfortunately, this is positioning. And I need to make sure I locate the right position because 4 is actually up. I need to be going down 4, so that's the right positioning. Once I have my 3 sides of the triangle, I want to use exact values whenever possible. So I have 2 sides of the triangle. I try to keep all the ratio parts exact. Okay, so sine theta works out to be -4/5. Tan theta works out to be, that's a positive slope, and it works out to be -4/-3, which is +4/3. And notice that that is a positive slope through there. It doesn't actually ask us to solve for the angle, but let's solve for the angle anyways. Okay, so let's solve for theta, and let's undo that cosine. Okay, so again, be careful. Our input is going to be the ratio. The output is going to be the angle. Okay, so that's how the trig functions on your calculator work. So I'm going to do second cos of -3/5, and it gives us 126. And again, I'm going to call this theta 1 because it's from my calculator. 126.87 degrees. Now I'm looking at my picture. I'm trying to determine if that's the right location. 126.87 degrees is in the wrong quadrant. It's in the wrong location. It's up here. Okay, and this has the same cosine ratio. Okay, this one has a cosine of -3/5. This one, the red position, also has a cosine of -3/5. So our theta 1 position was not the correct answer. It was, what was it again, 126.87. 126.87 degrees. This is a wrong one. This does not match quadrant 1, so I'm going to have to use some symmetry to get the other angle. So I know that it's 126 degrees from 0 to the right, so I need to go backwards from 360. So my theta 2 angle is 360 going backwards, theta 1. Okay, that ends up giving us 233.13 degrees, I think. Okay, so that gives us our angle measured in standard position to the point that we are describing. The quadrant with this ratio, the fourth quadrant, quadrant 3. So I need to make sure that my answer is in quadrant 3. So how can we find the other trig ratios given one ratio, z signed? Why do we need the quadrant? So we find the other ratios by solving for the unknown sides. And we try to keep those in exact value. Why do we need to know the quadrant? So we need to know the quadrant. Okay, so we need to know the quadrant because there are two possibilities. Okay, so there's always two possibilities, and we want to choose one if possible. Okay, so we want to narrow it down to one if possible. Okay, now if we can't narrow it to one, we have to give both solutions. If we're being asked to solve for the angle from the ratio, if we don't have any indication of which quadrant we really should be in, we need to make sure that we give both possibilities then.